Hey folks, so chapter 5 in the textbook that we're currently using had a lot of concepts in it, so much that I wanted to break them into pieces, and so we didn't, lump it all together, and so we could focus on one concept at a time. The first concept that we covered was running code conditionally, right? So, based on a condition, you would run some code or you'd run some other code, or maybe you wouldn't run any code. But instead of running code top to bottom, as we had done prior to that, we learned to write some if statements. And in if statements, again, it looked on the condition, and then based on the conditions, it determined what code to run, if any. Okay? And that was the first half of the chapter. I said if statements make our programs smart. Right? Remember that? Hopefully everyone remembers that. Right? It allows our programs to make decisions based on conditions just like we as humans do. Right? Remember that? So that's the benefit of if statements. It makes our program smart. What we're going to learn next is not an if statement. What we're going to learn now is running code continually or looping code. Continually means what I mean by this is you can write code once and execute it many times. So you can write a couple lines of code and then loop those lines to run many, many times. If statements make our program smart, loops make our programs powerful. Makes our programs powerful. Let me give a demonstration of what I mean. On Amazon.com, you can see I bought a new jacket here. But maybe I didn't know what kind of jacket I wanted to buy. So I'll search for Prime wardrobe men's clothing. Okay. We've all done this before. We've all searched for something on Amazon. You notice how I just keep scrolling, keep scrolling, keep scrolling, keep scrolling, keep scrolling. Notice at the bottom it pages. Okay. So what I'm looking at here, you might think is a whole lot of code to do this. And big picture, you'd be right. Big picture, there's a whole lot of code on Amazon.com. That's not what I'm saying, that there's not a lot of code. But somewhere on Amazon's website, there's a chunk of code that reads a single product at a time and places that single product into a grid. And that's what we're looking at. So it reads the product from a database and then puts that product information into a grid. And then that code that does that takes a single product and puts it onto a grid, that code is executed in a loop over and over and over again until all the products that are read out of the database are put into the grid. So behind this Amazon.website, so a little chunk of code, let's just call it 10 lines of code. So 10 lines of code put this picture here, puts the heading here, puts the link here, puts the button here, okay? Those 10 lines of code are iterated over and over and over again to fill this page with products. And so to the end user, you're like, oh my gosh, look at all these products. You got pages and pages of products that are being read out of the database one at a time and then put on the page using a loop. Same thing happens on Instagram. We all got Instagram on our phone, right? Most people have, no. At one point, we had Instagram on our phone. Is that true? No? Okay. Most people have Instagram on their phone. I've kind of gotten off social media a little bit, so my Instagram's old. But at one point, I had my phone. Takes a single post and puts it on your feed. As you scroll that loop, the more you scroll down, each post is populated by a loop. As you scroll down, that loop continues to run and populate your feed as you scroll through Instagram. Right? Facebook feed, same thing. Twitter feed, same thing. All these applications that we use on a daily basis, they all have if statements in them, and they all have loops. Okay? So when I'm talking about the fundamentals of coding, if statements are critical. Okay? If you write software, an if statement is fundamental to what you have to learn because it runs code conditionally and it makes our programs smart. If you write software, loops are fundamental to what you have to learn because it takes a little bit of code that's functional and it repeats it as many times as you need. Right? So hopefully that communicates to you why this is important. Loops are important because they're just as foundational to computer science as it can get. Every application uses loops. Every application uses if statements. Every website uses these things. Every mobile app. So on and so forth. When it comes to if statements, we had if, we had if else if. We had nested if statements, and we had switches. These were all variants of what we learned. When it comes to loops, there's a couple of different loops. Again, foundationally, they're different, right? So just remember, running code repetitively is a loop. Running code conditionally is an if statement or a switch. When it comes to loops, there's a few different types. We're going to start with one at a time. The first loop is a while loop. This is the first loop that we're going to run. Even though there are different kinds of loops, okay, even though there are different kinds, they all have the same components. They're all kind of made up of the same components. Okay, so when you're talking about the components of a loop, they are the same regardless of the type of loop. We're going to learn 3 types of loops, but they all have the same components. Okay, so before I tell you about the loops, I'm going to tell you about the component. Component number 1. The control variable I call it the control variable. The book, you might hear it called the index. All right, it might be called the index, but I call it the control variable. It's called the control variable. The control variable is used to determine used in part to determine the number of loops. Okay, so how many times are we going to execute this code? Are we going to execute this code 5 times repetitively? Are you going to loop this code 10 times, 100 times, 1,000 times? The control variable controls that, right? The control variable controls that. Very commonly, the control variable is just given the identifier of an I. So commonly, control variables are called I. I for index. So we know how to declare a control variable. On line 32, we are declaring our control variable, right? Remember, we can also initialize a control variable. Declare and initialize our control variable. So here I have integer I equal to 0. Part number 1 of all these loops is your control variable. Component number 2. You need to, every loop will test the control variable in a condition. This is where it gets confusing because if statements are conditional statements. But we're not using the keyword if, obviously. We're using a loop structure. But the condition, like in an if statement, our conditions were ultimately true or false, right? If grade is less than 4. If grade is less than 4, is that true or false? All of our if statements evaluated to true or false. They were a condition evaluating to true or false. Same thing here. In our testing the control variable, we're testing it in a condition that will evaluate to true or false. All right. Number 1, declare and initialize a control variable. Step 1. Step 2, test the control variable. Keyword, while. Hey, at least a while loop, just, the keyword is while. Well, that makes sense. While loop, keyword while. Parentheses. What goes in the parentheses is our test. Test the control variable. While I is less than 5. I less than 5, true or false? Well, I is 0. 0 is less than 5. That's true. 0 less than 5 is true. If the test returns true, the code block is executed. The while code block is executed. The while code block is right here. If, better yet, not even if, while the test returns true. See how it's very similar to an if? Inside those parentheses. So how's it different? How's a while different than an if? Well, an if is either true or false. It either doesn't execute or it executes once. So an if executes 0 or 1 times, right? Does that make sense? An if statement executes the code block 0 or 1 time. A while executes the code block 0 or many times. Big difference. An if statement is 0 or 1. A while is 0 or many. So how do you know whether to use an if or a while? Well, it depends on what your program needs. Do you need to execute, in the real world scenario, do you need this code to run many times? Then you're probably using a loop. If you just need it to run 0 or 1 time, then you're using an if. So it depends on the real world scenario, whether you're using an if or a while. So step number 2 is testing the control variable. Here's your test. Notice this could look a whole lot like an if statement if I just replaced the keyword. Literally, it's the same thing. You got the parentheses and you got the block of code. So is 0 less than 5? Yes. While the test returns true, the while code block is continually executed. So what do I want to do in my statement? I'll do a console.writeLine. Body of the while loop is running. And then what I'm going to do is I'm just going to print out the value of I. Keep in mind, I was set to 0. Is 0 less than 5? That's correct. So this will say the body of the while loop is running, ... And then it'll just say 0. So it'll print out I. Component 1. Declare and initialize the control variable. Component 2. Test the control variable. Component 3. Modify the control variable. Those are the 3 components that are important on all of our loops. We're learning one loop, which is a while. I is our control variable. We declare and initialize I. We test I inside of the parentheses. And then we have to modify I. I++. Modifying I will ultimately make the while become false. And just to demonstrate, I'll do a thank you for playing. A little write line that kind of ends our program. So I loops when it's 0, it loops when it's 1, it loops when it's 2, it loops when it's 3, it loops when it's 4. At some point, I will go to 5. Is 5 less than 5? No, 5 is not less than 5. So the while loop ends, and then it continues on running our program, and all that's left is to say thank you for playing. Does that make sense so far? what if I wanted this to, what if I wanted this to print out? I got 100 products. I got 100 products in my database. So I want this loop to loop from 0 to 99. How would I get this loop to count basically to 99 instead of just looping the few times that it did? So this is my question. How can I change my loop to iterate through 100 times instead of what it's doing now? That's my question. I'm waiting for an answer. So I'll wait for either Discord or someone to raise their hand. The question is, how do I get this to loop? If I'm pretending this was products in my database, how do I get it to loop through 100 products? Yeah, change the 5 to 100. I said I'll take a raise of hand, but nothing to be sorry about. I'm not worried about it. What does this then look like? So if I figure out how to put a product onto a page one time, do you see how easy it is to repetitively do that? Do you see how this makes a program powerful? You write a little bit of code and then just continually run it. Adrian.
Will it crash equal like I equals I?
Will it crash? Well, let's think about that.
Like wouldn't it just run a regular crash?
What is that really doing?
I'm talking about like up there.
Oh, okay, let's bring it back. Right here?
No,
While I is less than I.
I'm saying it's equal to I will crash.
While I equals I. Let's think about that. Does 0 equal 0? Yes. Then I goes to 1. Does 1 equal 1? Yes. So it loops. Then I goes to 2. Does 2 equal 2? Yes. So the question is, will this crash? And the short answer is they have a name for this. Infinite loop. The loop goes on infinity war. It goes on infinitely. I is typically just going to be an int because it's a whole number, but it could be another data type.
I was wondering if it was like going to stop once it reaches the limit of the data.
Yeah, eventually. Yeah, good question. If I is an int and we break the data type, I don't know what's going to do. Probably this is going to crash.
2 million. It's like 2 million something.
Yeah, we got to wait a while.
We're already halfway there.
Oh, there's a few numbers there. Oh, hold on. We're at 1 million?
Yeah, we're at a million.
The suspense is killing me. But to answer your question, this thing called an infinite loop, typically what it does, have you ever had to force close an application that says program not responding? Okay, that's typically what an infinite loop does. It'll cause your program to crash. Okay, generally what that means is that you coded something wrong, right? So very often in this class, if you just remember, like if you launch your program and it says program not responding, probably it's an infinite loop, at least in this class. Okay, so just remember that if you launch a program and it says not responding, not guaranteed that it's an infinite loop, but probably is an infinite loop. Again, we're human, and humans tend to think that it's not our problem. Is that 2 million? Because that's going more.
Wait, it's way bigger than 2 million.
Is billion, right?
2 billion, yeah, 2,147,000,000.
Yeah, so we're not going to wait.
We can increment by like 10 though.
Here's, oh yeah.
Let's do it. Let's increment by like 30.
All right, instead of incrementing I by 1,
We'll do it by 100.
well, I times equals 100. We'll increment I by 100.
Okay.
Wait a minute. 0 times 100 is still 0 times 100 is still 0. Let's see. 1 times 1. Well, 2 times 100. Yeah, let's see. That should work. Huh. It's still printing out. I mean, is it a glitch? Sure, it's a glitch. I equals 2. Okay. So Adrian pointed out we probably wouldn't do this ultimately. Let's take this out. Let's take it back to I is 0. I less than 5. This is another glitch. What I do, I did not modify the control variable. Remember 3 steps. Declare and initialize a control variable, test the control variable, modify the control variable. If you don't modify the control variable stays the same. If I is always 0, 0 is always less than 5, this is an infinite loop. And it kind of looks the same way. I guess what we're looking at here is an infinite. Again, normally this will end up resulting in program not responding. It's behaving like this for now. Okay? So, again, if you don't code it properly, it'll be an infinite loop. Now, remember up here I said an if statement can execute 0 or 1 time. A while executes 0 or many times. What do you mean 0? What if I set to be I equal to 5? I is 5, while 5 is less than 5. Is 5 less than 5? No. So this body will never execute. All right? So a note about a while loop. All right? If you're taking notes on a while loops, a note to take about a while loop. A while loop is a pre-test loop. And what a pre-test means is that you test the condition before the body executes. Pre-test means you test the condition before the body executes. The body is what's in the curly braces. The code block. Okay? Not all of our loops are pre-test loops. We got some good questions. We ready for our next loop? Silence over the crowd. The next loop is a do-while loop. It still has 3 parts. What are our 3 parts? Part number 1. Declare and initialize a control variable. Part 2. Test the control variable. Part 3. Modify the control variable. The do loop looks like this. Do while, I should say. The do while loop. Right? By the way, if I just type in the word while and then I hit tab twice, you kind of get the body of the while loop. If I type in do and I hit tab twice, you get the body of a do while. Those are your code snippets in Visual Studio. It kind of helps you with the syntax a little bit. So our control variable, they typically call them I. I declared I right here. So I won't use I here. I'll call this one Y. Int Y equal to 10. Here's the body of our loop. This is step 1. Declare and initialize our control variable. Y is our control variable. While Y is greater than 0. This is our test of the control variable. Notice our test goes in the parentheses. Just like an if statement, our test goes in the parentheses. Just like a while loop, the test goes in the parentheses. What goes in the parentheses evaluates to true or false. It has to. They call it a Boolean expression. Boolean expression. It's something that's, once you express it, it's going to be true or false. While Y is greater than 0. We start off here. Body of the do while dot dot dot. And again, I'm going to print out Y here. Let me comment this out. All right, I'm going to comment out the while loop, and I'm just going to focus on the do while. So our control variable is 10. Here's the body of the do while. While Y is greater than 0, 10 is greater than 0, that's true. So this will evaluate to true. What am I missing here? Of course, I'm missing the modify. So ultimately, if this is true, if 10 is greater than 0, we have to modify Y in such a way that at some point it's not going to be greater than 0. So maybe each time I'll say Y minus minus. I'll decrement Y by 1. Notice, body of the do while, 10, 9, 8, 7, 4, 2, 1. It's looping. It's doing the same thing as a while loop. Then you might wonder, well, why do I need this? If they both just loop, what's the benefit of one over the other? Here's the big difference between a while and a do while. A do while loop is a post-test loop, meaning it tests the control variable after the loop body executes. And by loop body, I mean the code block. What does that really mean in like English terms? A do while executes one or many times. Remember that a while is a 0 or many. A while loop is 0 or many times. Because if this is false, the body never executes. The do while is at least one time, one or many, right? So again, an if is 0 or 1 times. A while loop is 0 or many times. A do while is a 1 to many time. How do you know what you need? It depends on the scenario. It depends on the problem that you're trying to solve. If you have a scenario, hold on, I got a disk. Okay. If you have a scenario for whatever you're trying to solve, you got to figure out what control structure am I using. Remember, the title of this chapter is just control structures. They control the flow of our code. Okay? Do whiles are, in my experience, not as common as the other loops. It's not to say that you'll never use them. They exist, other programmers use them. But in my experience, they're just not as common. Again, code snippets help you. While tab tab, do tab tab. Because as you're learning the syntax of these, where do the curly braces go? Where do the semicolons go? Again, all you have to do at this point is replace what's in the parentheses with your conditional expression. Something that evaluates to true or false. You replace the word true with something that evaluates to true or false. So the first kind of loop is our while loop. The second kind of loop is our do while loop. They are all used for the same purpose, to execute code repetitively. How we doing, everybody? We good? Just check on Discord. Not much going on Discord. There's 3 loops that we're covering. We've covered 2 of them already. Here comes the third one. Third one has the same 3 parts. We know the 3 parts. 3 parts are easy. Declare and initialize the control variable, test the control variable, modify the control variable. Those are the 3 parts. The beauty of this third one, this one's called a for loop. Watch what happens when I hit 4 tab tab. 4 tab tab. Inside these parentheses now, there's a lot going on. Well, what's going on here? We've got a control variable, I, that's been declared and initialized. We've got a test. We're testing I to be less than or greater than or equal to something, and we're incrementing I. So the beauty of our third loop, the third loop is our for loop. The beauty of a for loop is that all 3 parts of the loop are done in one line of code. The thing about a while loop and a do while loop, okay? For the sake of this argument, let's just say in a while loop, we declare and initialize I on line 5. Let's say that our while loop is on line 100. And let's say that our modification of I is on line 1000. Okay? The downfall, if you will, of a while loop and a do while loop is that the 3 parts can be spread throughout hundreds or thousands of lines of code. Does that make them impossible to work with? No, but does that make them kind of challenging to work with at times? Yes, because to understand the loop and how many iterations it's going to do, you need all three parts. You need to know what your control variable starts at, you need to know how it's being modified, and you need to know how you're testing it. You need to know all three things to understand all parts of the loop. Well, the beauty of the for loop is that it's got all three parts in one place. It's all right here. So if I say I is 0 while I is less than 10, increment I by 1, again, in here's the body of the for loop. What happens the first time through? Line 79 hits. We start off I at 0. Then we test. Is 0 less than 10? Yes, it is. So let's run. This is the body of the for loop. And I'm just going to print out I, which is our control variable. If I run this, you can see I starts off at 0. It goes up until I is equal to 9. Ultimately, it stops at 10 because I increments to 10. Is 10 less than 10? 10 is not less than 10, so it never prints out the body of the for loop. Okay? The part that's most confusing about this for loop, when I was a beginner, the part that's confusing is this. Step 1 is you declare and initialize, then you test. So you do this second part, first part, step 1 of a for loop, it runs that. Step 2 of a for loop, it runs that. If that is true, it goes into the body. After the body, then it increments I. So that's your order of operations. That was confusing to me. Why was that confusing to me? Because I thought it would just go straight across. I thought it would do this, then this, then this. That's not the case. Okay? So maybe I shouldn't have even told you what I thought when I was learning programming, but maybe that helps. It doesn't do that. Okay? What it does instead is it starts here, then it goes here, then it goes to the body, then it increments your control variable, or I should say modifies the control variable. Does it have to go up by 1? No. Could it go up by 2? It could go up by 10. It could multiply by 2. It could divide by 3. You just got to modify it. You could do I plus equals 2. That increments I by 2 every time. It doesn't have to increment by 1. You just got to modify it. What happens if you don't modify the control variable? Infinite loop. You got to modify the control variable. These are often, for loops are often called count control loops. They're called count control loops because I can look at it and I can count how many iterations. An iteration is a single time through the loop. So I can count the iterations. I could say, okay, I is 0. 0 is less than 10. So that's the first iteration. 0 goes to 2. 2 is less than 10. That's the second iteration. 2 goes to 4. 4 is less than 10. That's the third iteration. 4 goes to 6. 6 is less than 10. That's the fourth iteration. 6 goes to 8. 8 is less than 10. That's the fifth iteration. 8 goes to 10. 10 is not less than 10. So you're done. Right? 5 iterations of this loop. 0, 2, 4, 6, and 8. 5 iterations. again, what have I just done in this lecture? In this lecture, I just sat here and I taught a concept that is as easy as teaching how to shoot a free throw. I could tell you how to shoot a free throw. I've told you this last time. I could tell you where to plant your feet. I could tell you how many times to dribble the ball. I could tell you how to bend your knees. I could tell you to flick your wrist. Okay? But if I tell you how to do these things, does that make you good at shooting a free throw? No, not at all. How do you get good at shooting a free throw? You got to practice. You got to practice at practice. That's what this is. This is practice. We're at practice right now. And you got to practice at home. Who was the best basketball player? Was it the one that only practiced at practice? No. The best basketball practice was the one that kind of, the people that just kind of enjoyed it, right? And they'd get together with their friends on the weekend and would do this kind of stuff, right? That doesn't mean, you had to be the best to make the team, right? But I'm just saying, if you want to be the best, you're going to have to put in some extra time, do that kind of stuff. Probably you're just going to have to practice while you're at practice. But if I could get you to practice at home too, that would, make a big difference for everyone. That's what this is. I just went through all the basics of the loops, okay? That does not mean that you guys are good at this. You're going to have to practice. We're at practice. What is practice? Practice is labs, okay? The game is the hands-on test. Right? You win the game when you pass the class and you pass the hands-on test. But certainly, just practicing at practice might not be enough for everybody. Some people might have to practice at home to really get this stuff. While, do while, for, these are all the concepts that we just covered. Can you have nested things? Can I have a for loop with an if statement in it? Yes, you can. Can I have an if statement with a for loop in it? Yes, you can. Can I have if, for, all nested within one another? Yes, you can. These are all things that are possible. Complex real-world problems take complex code to solve. Okay? So all these things can be nested within. Can I have a do while loop, and inside of the do while I've got a for, and inside of the for I've got a while loop? Yes, I could have loops inside of loops inside of loops. All right. Again, as you understand one, you got to understand one at a time, and then you can start to understand what it means to put one inside of one. Okay, we're not at that point yet. Okay, we're not at the point where we can do nested loops yet. I got to get you to understand one before you understand two or three. We are going down the mountain and trying not to die for the new people. Okay? All right. When it comes to loops and Gooeys, okay, loops and Gooeys, sometimes, if you are in a console application, you might need a loop to solve a problem. And you might solve that same problem differently with a GUI. Okay, for example, you might have a loop that asks the user for a number. Please give me a number. Please give me another number. Give me another number. Give me another number. Give me another number. Okay, and in a GUI, you could just have 5 text boxes. You don't need the loop in the GUI. Okay? Loops are used in GUIs and they're used in consoles, but they're used a little bit more frequently in consoles. Okay? So specifically for teaching GUIs, we tend to make, for teaching loops, we tend to make a little bit more consoles dealing with our loops. Consoles are really good at helping learn and teach loops. Okay? But, again, because sometimes in GUIs, you might not need a loop in a GUI where you would need a loop in a console. Okay, so in this class, making up a number, 80% of the code that we write is going to be in a GUI. Okay, but some chapters, like loops, we might do a little bit more in councils, that other 20%, for the purpose of teaching and learning. Okay, it just works a little bit better. Last thing here is a breakpoint. Have I showed you guys breakpoints yet? Not this semester? Cool. We're almost done with the we're almost done with the lecture. Make a button called that says count. Will be called button count. For I equal to 0, for your control variable equal to 0 while I is less than 10. I'm going to call this label result. Label result dot text plus equals we're appending. This is appending to a label. When you say plus equals, you're adding on to the label every time. We're printing out I and following it by a line break. So if this run problem 2, you can see what I've done is I've appended my count to a label and with a new line every time. Now I plus equals 3. You can see what's happening, and you could probably trace it and understand it in your mind, why it's doing what it's doing. But sometimes when you're working with code, many times, especially when you're learning, it's not going to do what you want it to do. So the best troubleshooting tool in my tool belt, the best troubleshooting tool that I know to fix coding problems is called a breakpoint. So here's any one of you who has a coding problem that is your code's not working the way you expect it to. You wrote the code, it's not working. You don't know why. You call me over. I look at it for a minute. I don't know. I look at it for 30 seconds. I look at it for 2 minutes. Okay? Not long though. My point is I don't look at it for long. I look at it and I look and I look. If I don't see it right away, I use a breakpoint. A breakpoint is a way to stop your code while it's executing and watch your code execute line by line. And what happens when you watch your code execute line by line is you can look at your variables and look at their values and determine if it's going the way you would expect it to go. Okay? So let me show you how to insert a breakpoint. I'm going to click on line 24. Notice where I click right over here to the left of the line 24. There's this little gray bar right here that I can click. I can't click on line 22. It doesn't let me, it only lets me click on certain lines. All right, so I can't click on line 22, but I can click on line 23. And click on line 24. All right, that's my for loop. That's inserting a breakpoint. That's telling Visual Studio to stop once it hits that line. Good programmers are good at inserting breakpoints. All right, that's all there is to it. Troubleshooting. Yeah, something to show here. This is kind of a little silly joke thing that we got. So, got these little rubber ducks, right? You can't see this. I literally have, if you're on Discord, I literally have rubber ducks in my hand. Little rubber duckies like you have in the bathtub, little kid bathtub, right? Okay. This is also a form of troubleshooting. It's called rubber duck troubleshooting, rubber ducky troubleshooting. It's kind of silly. Maybe you've heard of it, maybe you haven't. Rubber duck troubleshooting is the idea that as humans, we tend to blame other things on our problems. My computer's not working the way it should. It's not the code that I wrote. It's Visual Studio, it's my computer, it's Windows 10. It's not my fault. I wrote the code works, but my computer is acting up. It's just in our nature. It's hard to not be that way. It's in our nature to do that. Now, not everyone is that way, right? And in fact, it's better to not be that way. It's better to accept all the things in your life as your, okay, whatever. These rubber duckies come in handy because what these do is, the idea behind this is that you now have to explain your code to someone else. You explain your code to the rubber duck. Okay, so what you do is when your code's broken, you take the rubber duck, you put it on your keyboard, and you say, okay, on line 1, rubber duck, this is what I'm doing. On line 2, rubber duck, this is what's happening. On line 3, this is what's happening. And you describe your code to someone else. And oftentimes, just by doing that, it makes you slow down. And by describing your code, you can oftentimes find a mistake. You say, oh, wait a minute, rubber duck, that doesn't make sense. Right? Okay, so rubber duck troubleshooting, kind of silly, but it's a form of troubleshooting. And what it does is it makes you critically look at your own code. Because generally, you write code and you go, it's not my code that's a problem, it's something else. Okay? When in reality, it's probably the code that you wrote. Okay? So once we get past rubber ducky troubleshooting, if you talk to the rubber duck first, you critically look at your code, and you still can't find the problem, that's when we go to breakpoints. Okay? Here's how you work with the breakpoint. Instead of clicking debug start without debugging, we click on debug start debugging. When you hit start debugging, now it's going to hit your breakpoints. If you start without debugging, it'll skip over the breakpoints. When you start with debugging, notice it's already doing something over here. It looks different. All right, this is debugging mode. I'm going to click on count, and this tends to freak people out. I don't know what it is because Visual Studio looks different. People tend to get overwhelmed by all this. We got this stuff going on over here. I don't know what this is. I don't know what any of this is. I don't like it. And you just click on stop and let me not do that again. Like that. Sometimes people just get freaked out by this window. You hit this debugging, and basically it's like you're hitting the stop sign. The stop sign's got the little yellow arrow on it. And you're like, I don't understand. What's happened is on line 24, it's about to execute this chunk of code. It's about to declare and initialize I to 0. This control right here is how you go line by line. Notice F11 does the trick. But this is called the step into button. And notice once I click this, okay, I is set to 0. I can actually see down in this window, see where my mouse is? You see the variable I? You see it has a value of 0. So I can understand that at this point in the execution of the program, I is 0. If I step into again, notice now because 0 is less than 10, it goes into the body of the for loop. And you can see that it'll print out, if you hover your mouse over I, you can see I is still 0. Now it's executing I plus equals 3. So 0 goes to 3. Is 3 less than 10? I is 3. Is 3 less than 10? It even tells you, yeah, that's true. So it's going to go into the body of the loop. It now prints out 3 to the label. 3 goes to 6. It tests, is 6 less than 10? Yes, it is. It prints out 6. 6 goes to 9. Is 9 less than 10? That's true. Prints it out. 9 goes to 12. Is 12 less than 10? That's false. You can see where the code goes. 28. And then you hit next and the program's kind of done with that block of code. So breakpoints, stepping into breakpoints and watching the values of your variables changed are fantastic troubleshooting tools. They're better than rubber ducks. However, that's kind of a programmer joke. Ha ha ha, rubber ducky programming or rubber ducky troubleshooting. All right, so we now know how to set a breakpoint. Once you get into this dispose, you just click continue. Just click continue. Because you didn't write that code. You don't got to worry about this dispose. Like the program's closing. You don't need to step through as your program's closing. Just click on the continue button and go back to your code. All right. So that's loops, and those are breakpoints. And then there's some code examples, and there's some practice stuff in the book. Okay? Which, by the way, this stuff in the book, these are good practices. Should you ever want to do, again, additional practice, you could always do that. All right, folks. That is the end of this lecture. Did I keep my promise? I said it would be around an hour. I got an hour and 3 minutes. I kept my promise. All right. Obviously, you're going to have questions. Anything right now, let me know. Questions, comments, concerns. If not, we have an hour and a half to start working on these labs. Okay. Chapter 5, Part 2 labs are open. Go ahead and get a jump start on them. I'm here to help and answer questions.